Hello everyone, today we will see the working of op-amp as differentiator. This is a circuit for op-amp as differentiator. The input voltage Vi is given to inverting terminal of op-amp through capacitor C. Non-inverting terminal is connected to ground. The output voltage V0 is given as feedback to the inverting terminal through the resistor RF. Now let us derive an equation for the output voltage V0 for this circuit. Let us consider the point here at the inverting terminal as point A, and let us denote the non-inverting terminal input side as point B. Now we'll start the derivation. First we'll write an equation for the current through capacitor, that is IC. We know that a current can be written as rate of change of charge, that is I write it as d by dt of QC, where what is QC? QC is the charge across capacitor. Now I can write QC as Q is equal to C into V. We know that Q is equal to C into V, where C is the charge of the capacitor and V is the voltage across the capacitor. So let us denote the voltage across capacitor by Vc. And C is the capacitance. Since it is a constant for a given capacitor, we rewrite this equation as C into d by dt of Vc, voltage across the capacitor. Now I can write this as C into d by dt of voltage across the capacitor. The voltage across the capacitor, I can write it as the voltage between the two ends of the capacitor, that is Vi minus Va. So this voltage across capacitor Vc, I write it as Vi minus Va. Take this as equation 1. Now we'll see what is the voltage current across the resistor RF. Let us denote the current across RF as IF. So IF is equal to, we know that I can be written as V by R. So the voltage across the resistor RF is voltage between the two ends, the voltage difference between the two ends of the resistor. So Va minus V0 by RF. Let us take this as equation 2. Now according to ideal characteristics of op-amp has infinite input impedance. The input impedance is infinite, that is the current reaching the inverting terminal will not flow into the input terminal because of the high input impedance, and it will flow entirely through the resistor RF. This we are getting because we are assuming that the input impedance of the op-amp is infinite, that is current through capacitor C is equal to current through feedback resistor IF. Now we substitute IC and IF from equations 1 and 2 in this equation 3. Substitute 1 and 2 in 3. So what do we get? C into d by dt of Vi minus Va is equal to Va minus V0 by RF. Let us take this as equation 4. Now according to the concept of virtual ground, we'll apply the concept of virtual ground. What does the concept of virtual ground say? The concept of virtual ground says that voltage at inverting terminal is always equal to voltage at non-inverting terminal. That is Va is equal to Vb, but the terminal B is connected to ground, that is voltage Vb is equal to 0. So implies we get Va is equal to 0 since Vb is equal to 0. Take this as equation 5. Substitute 5 in 4. So what do we get from this? So here we have in equation 4 C into d by dt of Vi minus Va, which is equal to 0, is equal to Va, that is 0 minus V0 by Rf. So solving this equation, C into dVi by dt is equal to minus V0 by Rf, or we get minus V0 is equal to Rf into C into dVi by dt. I can write this as, by taking this negative sign that side, V0 is equal to minus Rf into C into d by dt of Vi. So the output voltage V0 is a derivative of, or a differentiation of, input voltage Vi. Hence our circuit works as a differentiator. And this is the equation for output voltage of a differentiator circuit.